Hey everybody, it's Michael Antonio, and welcome to Importing CloudFormation with Ordered Transforms. Okay, so if you haven't seen the previous video on transforms, you might want to see it. I don't think it's required. But transforms are constructs, and transforms can process any data. So the transforms are split into L2 transforms and L1 transforms. The base class for an L2 transform is base transform. And base transform has an abstract method which is called by the L1 CFN transform shim. And I explained what transform shims are in the previous video, transforms an introduction. So the abstract method is underscore apply, and it takes a template, which can be any data, and it returns any data. Now the transform class, which is a subclass of base transform, has an abstract method which is called by underscore apply. So it implements underscore apply, and it has an abstract method apply, which takes a transform, which is an object, basically just a CF JSON type, which is really just an object type that can be serialized into JSON, and it returns a CF JSON type. And string transform is another L2 transform, and its abstract method takes the template in as a string and returns a string. And then the parser L2 transform, it has an apply method that is abstract and takes in the template as a string, parses that string, and then returns an object, basically a CF JSON type. Okay, and so basically, although mostly we've been using transform, and mostly I do use transform, there are all of these other forms of transform, and you can create your own as long as you're just using base transform as your base class. Okay, so order matters when using transforms. The joiner transform, which we discussed in transforms introduction, needs to run early so that subsequent transforms can act on strings instead of on FN join statements. And then string transforms have to run, well, when the template is a string. It needs to be a string. So the string replacer treats the template as a string and then does a split, just a regular TypeScript or JavaScript string split, and then it does a string join, and that's how it replaces substrings. You can create other forms of string transform, but I find that the replacer has been enough for most of my use cases. In import scenarios, string transforms have to run after the CloudFormation file has been read, but before the CloudFormation file has been parsed. In synthesis scenarios, we get the CloudFormation directly from either the CFN element or the stack, and we need to stringify that CloudFormation in order to run string transforms. And then in order to output in synthesis scenarios, we need to reparse the CloudFormation. And although you can do this, we would like to avoid multiple stringify parse passes for efficiency. And so we need to set things up so that string transforms can run in the correct order. Okay, so constructs in the CDK are enumerated in TypeScript property order. And properties in TypeScript are ordered as follows. So if you have number keyed properties, as such as in an array, then those properties are enumerated in their order. So property 0 will be enumerated before property 1, regardless of the order in which they were added. Symbol keyed properties are enumerated in the order that they were added in. And string keyed properties, which are the ones that we use in constructs because that's the construct ID that is used in the children array of the parent construct, and those are enumerated in the order they were added. So we need to be able to reorder our transforms so that they run in the correct order. That is, the string transforms all need to run together, and the JSON transforms all need to run together. And, we don't want to, like I said, we don't want to have multiple stringify and parse So we need to come up with some way of handling this. And the solution I came up with is order constructs. And these sit below the CFN element, stack, or custom transform host, which is the import scenario, and that's what we'll be looking at today. The CFN transform shims, these are the L1 transforms, are added to the correct order by their L2 transform. So the L2 transform can just be added to the transform host, the L2 resource, or the L1 resource, the stack, or the custom transform host. And then the shims will be added in the correct order under the target of the L2. And that'll make more sense when we get to the demo. Transforms can be added without orders, while string transform will add orders with a stringify or parser if they do not exist. And what this basically means is, if you're looking at the synthesis use case and you add a string transform, that will add the orders so that we'll do a stringify and a parse, and any subsequent string transforms will be added in between those two, and any transform subsequently added will be added after those. And hopefully that will also make more sense when we get to the demo. And you can change which order a transform favors by overriding the order property in your transform subclass. And then that way, when you add your transform, it'll get added where you wanted it to be added. And order constructs are always added to a target in the same order as defined by the import use case. So let's take a look at that use case. So when we're importing CloudFormation, we create an importer, and that's a custom transform host. And this applies transforms before creating the CFN include. Previously, we've been looking at the synthesis use case. And in that case, the transforms are applied at synthesis time after the CloudFormation is created. Here we have CloudFormation, and so the transforms are applied before creating the CFN include. And so the children of the importer are the orders first, and the first order is pre-reader. And pre-reader transforms run before the template is read. And so a good example of this would be calling a script to generate a CloudFormation file, or calling out to curl to download a CloudFormation file. Then the reader runs, and that basically reads the template file into a string. And now that we have the template file as a string, this is a perfect opportunity for us to run string transforms, and then we can perform string replacements on the template. And then once that's done, we can run a parser. And so we have the parser order, which hosts a parser shim that parses YAML or JSON or whatever format it is you happen to have. And then we could run transforms, and transforms run on the parsed object. So this is basically a JavaScript or TypeScript object that has already been parsed, and that itself can be stringified back into a string using JSON stringify. And when the orders are in place, transforms will be hosted in the _transform order. And then the writer runs, and the writer will stringify the template, and it will write it out to a temporary file. And that is because CFN include takes in a file name. It does not take in CloudFormation the way that it used to, which is too bad, but it's something I have to deal with. So that's what we do. And then we have the CFN include, which is created by the importer after you've added all of your transforms to it. Okay, so our use case obviously today is importing existing CloudFormation. So why would you want to do that? Well, in our case, we had a very large investment in a pre-CDK IOC technology, actually in two of them. We use the AWS StepFunctions Data Science SDK for Python to create all of our step functions, and we use Jinja extensively. And these were under active development. They may even still be under active development, and we did not want to give up our investment in these technologies. We didn't just want to change everything over to the CDK. And so we had this whole infrastructure for deploying these step functions, where we had our own servers, and we would deploy code to them that could read the step functions data science SDK uh, step function definitions, and then call the correct APIs to create those step functions. Well, why wouldn't I just do that with CloudFormation? The problem with this is that the CloudFormation generated by the AWS Step Functions Data Science SDK and by Jinja did not always work with the CDK toolchain. And so originally I came up with transforms as a way to fix overly complicated CloudFormation that didn't work with the CDK toolchain. And even sometimes things would work, and then there would be a bug in the CDK, which they would subsequently fix. But in the meantime, I needed the newer version of the CDK, and I needed to be able to deploy, and I needed a way to get around whatever the problem was with the CDK toolchain at the time. And so this used to be a very big problem in the CDK. Now it's not such a big problem. And so mostly I'm using transforms now as an escape hatch for complex pre-processing or post-processing of CloudFormation that can't be done with escape hatch methods. So I try to use escape hatch methods when possible, but sometimes I just need to edit the JSON. Oh, and it's demo time. Okay. So let's take a look at this template. This is a template that was generated by that data science SDK that I talked about. And when you have the data science SDK generate a state machine for you, it will generate it this way. So it'll have a description, which is CloudFormation template for AWS step functions dash state machine. And we would actually, for an application, we would generate multiple state machines. And since we're generating multiple state machines, I'd like to put all of those in the same template. And if I have this description, I'm going to get this description repeated for as many times as I have step functions that I'm importing. And I really don't want that. So I want to remove this description here. And we kind of saw that effect in an earlier video, where if you have a bunch of resources that create descriptions, they all get kind of smashed together at the end. It's very unpleasant. Okay, and then we have this logical ID state machine component, which is always the logical ID that gets generated by the data science SDK, which is really not what we want, because then I would end up with a template with multiple state machine component logical IDs, which is not going to work. So we need to replace that. And then at the end of this, there is a role, and I will frequently want to change the role that's generated by the data science SDK to a different role. So, I would just give it like a dummy role to write out, and then I would change it to a real role when I've imported it into the CDK. And so let's take a look at our lesson stack. So our lesson stack is ordered transforms, which I'm adding to my app. Here's ordered transforms, and what I do is, first thing I do is I output ordered transforms constructor begin, which gets written out here, and then the last thing I do is I write out ordered transforms constructor end, which is all the way down here. Now you'll see in this case, all of my transforms are actually executed in the middle. Now, previously, we've been running transforms as part of synthesis, and that would mean that they would all run after this end log line. But here, since we're going to be importing a step function, we'll be doing that as part of the create pass, and therefore all of our transforms will run as part of stack creation. So the first thing I'm going to do is I'm going to set the log level to debug using scoped logging. I have a video on scoped logging. It's called Synthesis and Scoped Logging, if you're interested in watching that. And the reason I set it to debug is because the transforms framework in my CDK library, CDK orchestration, will write out debug lines so that you can tell which transform is being applied and the order in which they're being applied. And then I have this import echo input step function, which is this is going to import the echo input step function, which is a step function here in this workflow template. Okay, so here you can see, here is my ordered transforms stack, and then it has import echo input, and that is this construct right here. If I come over here and we look at this guy, I want to go to the bottom of this, you'll see that this construct creates a role. So this is our step functions role, and then it creates a function, and that role can call this function, and this function basically this is just an inline Node.js function, and this is going to be called by the step function that we input, and I've given it the function name from the template here. So somewhere in here we say that we're going to do a lambda invoke, and we're going to invoke the function called echo input, and so I just created such a function in here so we'd have something to call. And then here is my data science SDK template import construct. This can import any template from the data science SDK, and you just pass it the template file, the logical ID that you'd like for your step function, and the role. And I think that there might be one or two other parameters, but I'm not using those for this. So the data science SDK template import is here. This is a construct, and it exposes the state machine that gets imported. And what it does is it creates a template importer, and you can see that here. So here is the role that we saw that I created, the lambda that I created, and here's our data science SDK template import construct, and it has an importer child. And so that importer child has these orders underscore prereader, underscore reader, underscore string transforms, underscore parser, underscore transforms, and underscore writer. And so this is the order in which things are going to run. So, and down here are the transforms that I've added. So I added a capture transform that allows me to capture the parsed and transformed template so that I can make some inferences about the parameters, which I do as part of the template importer, so that I make sure that I'm always passing values for the parameters so that they can be cleaned up by the CFN include. And then here's my data science SDK template cleanup construct. So this is a construct that knows how to clean up these templates, and this is the thing that's going to be doing the importing, and then therefore that's why it's parented to the template importer rather than being parented to this construct. And so you can see that here as a child. This is the cleanup child of the importer. And this cleanup has 3 transforms under it. And those transforms are the description remover. Let's go take a look at that. So our description remover is a transform, and it has an apply method. And what you can do with it is you can delete or what it does is it deletes the description and then returns the template. So that's pretty simple. Then we have a step function role arm transform, and this is also a regular transform. So again, it takes JSON in and returns JSON the same way that this description remover did. And so since it's working on a CloudFormation template, it will run through all the resources. If any of them are state machines, it will set the role arm of that state machine to the role arm that I passed in the constructor. So that's pretty simple. And if we go down here, we'll see that it also adds a string replacer called replace logical ID. And the joiner is the step function logical ID that was passed in. And the splitter is the state machine resource ID state machine component, which is the default name for step functions created by the data science Python SDK. And so that will replace the string for me. And so this obviously needs to run as a string transform. So first we have pre-reader that runs. There's no pre-reader, so because we already have the template on disk. And then the reader, and so it runs a file reader. And you can see that the file reader, even though it was not added first, it is run first because it is the first thing that is listed under these orders. And so the file reader shim is the first thing that runs. That calls back to this file reader, which reads the file into memory. The next thing that runs is the replace logical ID shim, which makes sense that because that's a string transform, and that is going to replace the state machine component with the logical ID that I asked it to replace it with, and then we're going to parse. So the YAML parser will run because this is YAML. I had to use a YAML parser. The normal JSON parser wouldn't do. And then we're going to run the transforms. And those are the description remover that we saw and the step function roll arm transform. And so those two run. And then you'll see that here. So here's the YAML parser, here's the description remover, and here's the step function roll arm. And the next thing is the capture shim. And the capture shim is the first thing in the writer. And that's why it was actually added first, because I want to make sure that before we actually stringify, that we capture. And so this will allow me, this capture shim will basically take a snapshot of the template, and it will allow me to look at the parameters of the template and make some inferences about how I should deal with those parameters when I'm doing my CFN import. And then so that's the capture shim, and then there's the stringify shim, which turns and that's this stringifier here, and this stringify will then turn the template into a string, which can then be written to a temporary file, and so that's the next one that runs. And then we have successfully applied all of these transforms to our importer custom transform host. And then that's the last line that is logged, but that's not the last thing that is done, because once these have all been applied, then we're going to actually do our import. And so the import that's done by the importer, it creates L1 constructs for every resource that it imports. And so here it created this echo step function, and that is the L1 step function that we get. And I'll show that line down here. So here's our template importer. Here are our cleanup transforms. And when we call import template, it runs all of these transforms, reads the file, runs these transforms on the file, and then does the CFN include. Here's our CFN include. It's importer imp0 in case we wanted to import the same template multiple times. I don't know why you would want to do that, but if you do, that'll work. And then it gets the state machine out of that. And this import template, you can pass properties to it if you want. In this case, I don't need to pass properties to it. If I needed to, then I would supply a way of passing, for example, parameter values. That's part of the import template props that it's possible to pass here. I just normally don't need to do that for this use case, so I don't have a way of passing those down. And then if somebody gave me a removal policy, then I could just apply the removal policy afterwards. And so that is basically what happens here. So now the output of this, if we take a look, we can see here's the role and the role policy. So we created a role, and then we created a lambda, which has its own role. And then we have our step function, which is this echo step function. And it's called echo step function because in my cleanup here at the bottom, I told it to call it echo step function. I told it that's what I want the logical ID to be, and that's what the logical ID is. It's echo step function. You can see that this has the definition string. That definition string, let's see, it's just basically that definition string that we saw in this workflow template here. It just puts it right in line, so that's no problem there. And then the state machine name is echo input, and that actually came from this template as well. That was up here. So basically, I was able to import this. My template does not have any description because I didn't add a description to it, and I removed the description from the imported template, and that's exactly what I wanted. I got the logical ID that I wanted, and I got the role that I wanted. So it actually is referring to the role ARN that or the ARN of the role that I created earlier. So hopefully that gives you some idea of why I created this whole transforms framework. Next time, I'll show you some of the things that I'm doing with it that are just not possible to do with normal CloudFormation escape hatches that are in the CDK. Maybe they'll add the ability to do this in the future, and I won't have to have such a complicated transforms framework, but I think I'll still have to have transforms in the future because I think it's kind of nice to be able to treat the template either as an object or as a string. And like I said, I'll show you some other uses of transforms in the future. But this was really the original use case, and so I thought it would be interesting to see how I did this. And, I used to keep just lists of transforms and string transforms and apply them, but I found that everything just worked better when I turned all of these objects into constructs, and it just seemed like a more CDK-like way to do things, and I've been very happy with this approach. So there you go. Thanks a lot, everybody, and I'll see you in the next one. Bye-bye.